Hello everyone, my name is Aidar, and in this video, exercise 6, we will talk about glacier data. The first thing that we need to do is to prepare the shapefile without the glaciers. In other words, the the HRU shapefile without glaciers, something like this. And we already prepared the glacier shapefile in the exercise 2 video, and now I will show you how to do this one. So, so we need to open our shapefile that we will use, where we need to cut out the glaciers shapes. We go to the Vector tab, Geog Processing Tools, and then Difference. Here in the input layer we have the HRU shapefile, and in the overlayer we have glaciers shapefile. And here we need to save to the file, HRU without glaciers, save, run, and here we are. We have prepared the HRU without glaciers. It will be important next when we will set up the RS-MINERV model. The glacial discharge data that we are using for the Zerashan River study is the Global PyGEM-OGGM Glacier Projections. These are provided by National Snow and Ice Data Center. And to get access to this data, you'll need to go to this link and go to the Data Access and Tools and go to the HTTPC file system. You can also access it differently, but I usually use the HTTPC file system. We need to log in here. If you don't have the login, then you need to sign up to this website. Next, go to this folder, and here you can see all datasets that are available. There are different datasets here, but we are interested in the glacial discharge for Central Asia. We can find here glacial runoff name for the file, but we cannot identify whether this file is for Central Asia or not. How do we know that this file is for Central Asia? Let's go to the documentation, user guide, and here we opened the documentation for this dataset. Then we go to the naming convention, and here we find out that RGI-6, a global inventory of glacier outlines, were used to geolocate the data. Thus, the global terrestrial network for glaciers region numbers are used. So we need to go to this global terrestrial network for glaciers. And here in the description, it doesn't say which number corresponds to the Central Asia. So let's go further and open the scientific data and identifier link. And we can find in the first link the same website. Here in the second link is the documentation for RGI dataset, and here we have the chapter regarding the glacier regions, and here we can find the map that illustrates RGI regions, and here we can find that number 13 corresponds to the Central Asia, and we are interested in it. Therefore, you can scroll down and find RGI 13 and download the data that you need. In order to download the data in this file system, you need just to click on the file that you need and it will start the download. In this study, we already prepared the data, so you can just follow the Dropbox link and find the necessary data there. Next, we need to open RStudio and open the glacier extraction script. The first two chunks you can run. You don't need to change anything in these two chunks because first one contains libraries and the second one contains the functions that you need for the script below to perform data processing and preparation. For example, this one appends the required attributes to the table for the discharge station. Next, we go to the Glacier outlines. It currently works only with the RGI 6.0. And here you only need to change the directories to the files. For example, here we need to change the path to the folder where you store all your JS files. In my case, it's here. For example, I insert here my directory and I have here backslash, which I need to change to slash, and I use the control F method. But in the bottom, in the document, there we have some instances of backslash, which I don't want to change. So in that case, I cannot change all backslashes into the slash in the whole script, and I choose the where I want to change backslash, click in selection, and then replace all. And it will replace only here where I selected, not in the bottom where I don't need to change it. For example, here, it is not changed. Now, next line is the glacier outlines from RGI. And here, the basin outline, if your basin shapefile has the same name and it is also stored in the same GIS path as mentioned here, then you don't need to change this line. And here, if you want to save this file, RGIS intersection with basin shapefile, in the same GIS path as it's mentioned here, then you don't need to change here anything. So let's run. It worked, and then we can go to the next. Next, in the extract and aggregate glacier discharge for each glacier part, we need to download the data before we process this data. And previously I showed you how to download it manually, but here in this script, it shows the link to how to download in more automatic way. You need to go to the link here and you need to log in to your account. You need to have the eras.usjs.gov account. And after we log in, we need to specify the area of interest where we download our data. And you can do it like this by drawing the polygon, or you can prepare the outline or area of interest before that in QGIS. And to prepare that outline is very easy. You just need to have your Zerafshan River Basin. And here we need to create a new shape file, which will have the polygon type, and press the toggle editing and then the add polygon feature. And here we can left click with the mouse to create the polygon. Then right click to save it. And then your polygon is ready. You can save it and use it here to specify your area of interest. Next, you need to specify the dates that you need for this dataset. And then you need to click the download script. After you downloaded the script, it will appear in your downloads folder, and you do not need to open this script. You only need to copy the name of it, and if you have a Windows PC, then you can just click on the start and then type cmd to open the command prompt, and then you need to type Python and then insert the path to your script. Then the command prompt will find the script and it will ask for your ERS data username, the same username and password that we used to log in here. So you can just use it, and after you insert your login and username, the download will start automatically. And this automatic way of download your files will work only if you have Python installed. We can open the script that we downloaded, and here in the comments it says that it works in Python's versions 2.6 and 3.4 and others. And to run the script at a Linux or macOS machine, you need to open Linux or macOS terminal. On Windows, it's the command prompt here. And you need just to write Python and the path and the name to the script. And it says that it will ask for username and password and etc. If you don't have Python installed on your computer, you can just Google and install the Python from its official website, and there are plenty of YouTube tutorials how to install it on your machine. If you don't like this method and you don't like the method I previously showed by just clicking on the needed file, you can order files here. After you click it and press OK, these files will be processed and they would appear on the orders page. Order page is here. You just click on here and left click on the orders. And next the order page will open, and here you will have all orders that you made to download certain files. And from here you can download the zipped file. And after you downloaded all the needed file, you can open the R script that that is for glacial data, and here you can change the directory to the files that you just downloaded, and you don't need to specify each file individually. You just need to specify the folder where they are, and this line pattern glass runoff fix monthly will identify the needed files for the processing. And this chunk of the script will extract and aggregate glacial discharge for each glacier, and they will be aggregated by basin, and here the files will be saved in this directory. So if you need a different directory, you need to change this line. Next, the visualization. You need to specify the location where the files were saved previously, and they will be visualized. I just changed the path, and let's run it to see the visualization. So we have the 4 projections visualized in this script. Next, go to the basin aggregates. Here again it aggregates by the basin and save the files to the following directory. You need to change that line so you would have your files saved where you want. And next, in the back extension of Glacial Wet, we calculate average monthly glacial melt between 2000 and 2010, and you don't need to change any of this code except if you have a different time frame. For example, you have in 2020 and you have 2024. Then you can change the dates. And it also plots the hydrograph here. Next, we go to the reformat chunk where the data is reformatted. So the RS Minerv software could easily read these files. You do not need to change anything here except the time frame and the line of directory where we save the resulting file. Next is the visualization of the data that were just processed in the chunk before. Here is the glacier runoff that were resulted from the previous part of the code. And in the next part, we have the future glacial melt, which is prepared almost the same way, but it's not for historic, but it's for climate scenarios for future glacial melt. You can adapt here the passes where you save the file and the time frame that you need. And after we run this part, we can go to the visualization, the last chunk of the code where we can run and visualize the projected glacial runoff for future dates. And here we can see here the observation glacial runoff and the future projections for different climate scenarios. Thank you for your attention. If you have any questions, feel free to write us in the comments or write us an email. See you in the next videos.